Ed Paget here. Today I'm going to help you understand your scoliosis from your x-ray. Alright, the way I'm going to do this is a little bit different from how I normally do videos. I'm actually going to jump over to the computer and I'm going to take you through some x-rays and real life x-rays so we can look at them and help determine what you have to make sure you do the right rehab for your particular curve. So let's jump over the video and you can see what I'm looking at. By the end of this video, you'll be able to tell what type of curve you have from your x-ray. Now you can also watch this if you've just had an x-ray report, as I'll help you understand what the report is telling you. I'll help you with some of the language there. Now I'm going to be discussing the four main types of curves, which are the two types of C curve and the two types of S curve. Now these types of scoliosis don't have any known cause, which is why they're referred to as idiopathic, which is just a fancy way of saying no known cause. They commonly occur during adolescence, or in the case of a C-shaped curve in the lower back, that can come in later life. All right, so we have a left C curve. We have a right C curve, essentially the same curve, just going from different directions. We have an S-shaped curve, and you can see why it's called an S-shaped curve simply from its shape. And then a reverse S curve. And the most common one is the last one, a reverse S-shaped curve. And this is what people would refer to as an adolescent idiopathic scoliosis. And it most commonly occurs in adolescents or teenagers. And so they would have been investigated, but again, there's no known cause. And these curves account for 80% of the scoliosis curves out there. I'm also going to show you how to test your curves from home in case you don't have an x-ray, but we'll do that later. All right, if in doubt, you have to ask for an x-ray because an x-ray is the gold standard. Now, for example, some people might look like they have an idiopathic scoliosis, but really it is caused by something, and that's congenital. It means that they were born with it. For example, here we can see that there is a hemivertebra, which means half a vertebra, or some of the vertebrae are stuck together. Now on an x-ray, that can look like this. But your x-ray report will tell you whether or not you have a hemivertebra or a failure of segmentation. What type of x-ray should you ask for? A standing x-ray from the front and the back and the side is the best one to ask for, because this lets us know whether your hips are in line or one hip is higher than the other. Now we also like to have x-rays with no brace. The x-ray should include both hips, whole pelvis if possible, the whole spine definitely, and if possible the lower half of the skull and shoulder girdle. Now when should you take an x-ray? Well, if the child, assuming your child has an scoliosis, is still growing and their degrees are more than 30, they should be taken 4 times a year. Now if the curve is less than 30 degrees and has not progressed, then the x-rays can be taken just once a year. And the reason for that is that during the growth spurt of children, the curve can increase rapidly. Now for adults who stop growing, they can have an x-ray just once every 4 years, unless some sort of rapid change is suspected. All right, let's get to the curves and see what we can find here. So this is a single curve. We call it a thoracic dextro scoliosis, dextro meaning right. And the curve is referred to by the side of the convexity, or the long side or the apex. They're all the same thing. So when we look at a spine like this, we can divide it into 2 areas. There's the thoracic, and then there's the lumbar. And so the red line here is the thoracic, and the green line is the lumbar. The thoracic consists of 12 bones, or vertebrae, and the lumbar consists of the bottom 5. As this curve is in the thoracic vertebra, we can call this a thoracic C-shaped curve. Or to be more accurate, when we look at it from behind, we can call it a thoracic reverse C-shaped curve. Now you can see there's just one major curve here. We can also call that the primary curve. There is a corrective curve below it here, but that one is secondary to the primary and we're not going to refer to it here. Now, some x-rays are taken from the front. Now watch out for this because it can be confusing. Learn how to flip the x-ray. Now usually somewhere on the x-ray there'll be a little L or for left or a little R for right. This can help orientate you. So you can see here I've underlined the R with that red on the left-hand side. Now if there is no indication of which side is which, you can look at the heart, because the heart should always be on the left if you are looking at someone from behind. So you can see here I flipped that x-ray, circled the heart, and you can see the R is underlined. And after the R it says PA, which stands for posterior to anterior. So this is taken from someone looking at them from behind, which is the same way I like to look at x-rays when I'm looking at someone standing in front of me and I compare their x-ray to their spine. Okay, so let's look at a different type of curve. This curve is called a thoracolumbar lavoscoliosis, or as I like to call it, a left C-shaped curve when viewed from behind. Now you can see that the curve starts at the top of the lumbar vertebrae, where the green line is, and then it extends up into the thoracic vertebrae where the red line is. So that's why it's called a thoracolumbar lavoscoliosis, because the curve is in two different areas of the spine. Well, let's talk about double curves. Now we can call these ones a dextrothoracic, meaning right thorax, and lavolumbar, meaning left lumbar. But most commonly, this type of curve is called a reverse S-shaped curve. So when you look at someone from behind, this is the shape they will have. They will have a slight rib hump on their upper right back and a slight thickening on their lower left back. And you may even see the spine in this reverse S shape. Now these curves are actually quite balanced, meaning the top and the bottom curves are nearly equal. But it isn't always like this though. Sometimes one curve can be almost double the other curve. And whichever is biggest is referred to as the primary curve, which I mentioned before. And it's often best to start by treating the primary curve with exercises, as the secondary curve, the smaller one, will usually decrease if the one that's bigger than it is dealt with. Okay, so now you've seen an S-shaped curve, you've seen a C-shaped curve in both ways. And so what we're going to have a look at now is how you can actually find these things out from home without an x-ray. So some people don't actually want x-rays or repeated x-rays. And an x-ray doesn't actually take into account something called rotation. And that is where the spine will bend at this, rotate or bend at the same time it bends to the left or right. So in a thoracic curve with the curve apex on the right hand side, it will always be accompanied by right rotation. And I'll explain what I mean by that in a minute. But first I want to show you the Adams test. So the actual mechanics of the Adams test are quite straightforward. You simply ask a person to stand in front of you and you make sure their legs are straight, there's no knee bend. And you ask them to slowly bend forward, vertebrae by vertebra. And as they bend forward, the flexion, that's the movement of the spine that happens, will increase the rotation, and you will start to see a rib hump or a thickening in certain areas of their back. The reason this happens is that the flexion of the spine increases rotation. And rotation of the spine is increased by side bending. So where a person has a side bending or that curve in their spine will also rotate. So let's have a look at what the Adams test could look like. So imagine you're seated or crouched behind someone. You may see something like this. Now my focus here is on the upper right back where you can see the rib hump. A rib hump like this on the right will indicate that the rotation of the ribs is to the right. This is because the ribs are attached to the vertebrae. Now as they are rotated to the right, you will also know with some degree of certainty that the upper spine here has a thoracic dextroscoliosis, or a curve with the apex on the right, or as I call it, a right C-curve. So this is how the spine would look if someone was bending forward in front of you and had a rib hump on the right-hand side. So let's have a look how that looks for something slightly different. So reverse S-shaped scoliosis. Here you will see a hump on the upper right back, but also a thickening on the lower left back. And this is the most common type of scoliosis, and this is the most common type of, most common presentation you would see. When this person is standing up, you may notice that their right shoulder blade sticks out a little bit more than their left shoulder blade. Let's have a look at a C-shaped scoliosis here. So the apex will be on the left-hand side, which also means the rib hump will be on the left-hand side. So looking at a C-shaped curve, you'll have a rib hump on the left. Now for a regular S-shaped curve, this is less common. And when we actually see this in children or teens, it's often a sign of something else going on. So this could be some sort of cerebral palsy or paralysis or some sort of muscular abnormality. So Duchenne's muscular dystrophy or some other syndrome like Marfan's or neurofibromatosis. So it's worth checking if you have this pattern of scoliosis, if there's anything else going on. Now, don't freak out. It doesn't always mean that, but it's just less common. So what would we see here? We would see that rib hump on the upper left, and we'd also see a thickening on the lower right in the lumbars. Now, how can we measure this from home? There's a device that's very cheap and can be bought online, and it measures the rotation of the curve, or you can use this to measure the rotation of a curve of a family member. And it's called a Scolimeter. These can be a useful tool to track changes in curve rotation without multiple x-rays. A lot of my older clients don't like having multiple x-rays, and they're more focused on the aesthetics of their spine. So this is a great tool to notice any changes in the rotation. You can even use your smartphone with these as well. What you do here is you simply find the most rotated part of the curve. Then you place the Scolimeter on it, just like in this picture. And it will give you the angle of rotation. Now, as you use exercises to manage your curve, you can then track changes over time. The key here is to make sure you're in exactly the same position every time. I like to have people measure a mark on their shins where they are able to put their hands every time. Maybe that's 6 inches or 15 centimeters on the floor. Also, it can be helpful to actually count the vertebrae, either from your pelvis up or from your neck down, to make sure you get the same one every time. However you do it, make sure it's repeatable. Okay, so what we did here is we covered the 4 main types of curves, the 2 types of C curves, the 2 types of S curves. We looked at some x-rays, we looked at how to perform the Adams test, and we looked at the Scolimeter. Okay, so there we have it. Hey, if you like this video, make sure you check out my other videos on scoliosis here. Also, you can check out the playlist of scoliosis, and you can then watch all my videos on scoliosis in any order you like, and you can start to manage your scoliosis from home.